In this video, I'll go over vectors, also known as array lists, and answer the following. What are vectors? When do we use them? As well as how do we use them? And some practice using vector operations. Vectors are used to represent dynamic arrays. Dynamic arrays are arrays in which we have a flexible capacity. What that means is, for example, if we have an array of 4 elements, 1, 3, 5, and 7, a normal array, we would not be able to add more elements to this, as when we declare it, we have to specify the size and capacity, and we're not able to change that afterwards. However, in dynamic arrays, the way it works is that first, a new array is created with the same elements, plus it has double the capacity. So initially, here we have size 4 and capacity of 4. In the new array, we have, after adding an element, let's say we added 9, the size is updated to be 5, and the capacity is doubled to be 8. They are very similar to arrays in terms of many things like indexing. They start from the 0th index and so on. And this is like common behavior among vectors and dynamic arrays. Another important thing to note is that in C++, vectors are built into the standard library, which allows for automatic memory management. So we use vectors because they have a lot of helpful features like operations and automatic memory management, instead of like implementing dynamic arrays as an abstract data type, since we would have to play with allocation, deallocation, and so on. So vectors are useful when we have a collection of elements but we're not sure about the size of these elements. For example, if we initially had 5 integers and we store them in a vector, then that number changes to 8, then there's no problem, and we have a flexible capacity. And they're exactly like arrays in terms of like having a collection of elements of the same type. Let's look at the complexity of some of the operations in vectors. So some additional operations that we have in vectors that we don't have in arrays are insertion, deletion, and appending. In insertion, the time complexity takes big O of n, as well as deletion. Since, let's say we have an array of 3 elements here, so we have 1, 2, and 3. Those are indexed 0, 1, and 2. Let's say we want to add insert an element into the first index, then we would have to shift those 2 elements here. One position to the right, and then insert the element at this index. And this really depends on the size of the vector, so it takes a big O of n and a linear time complexity. Similarly for deletion, it is the same thing. If you want to delete an element in the beginning of the list, then in the worst case, we're going to have to shift everything backwards by 1 position, which may be very large depending on the input size and the size of the vector. But for appending, it's just constant time, since it does not depend on the input size. We always append at the end of the vector, and it's just always going to take constant time. So how do we use vectors? In C++, we include this vector keyword here, and then we use it here to declare a vector. So you follow this format. So you start with the keyword vector, and then inside these greater than, less than signs, put the type, and then the name. We have a list of functions and operations that we can use on vectors, such as front and back. Those allow us to access elements in the beginning and at the end of the list. So front allows us to access the first element in a vector, and the back allows us to access the last element. So to visualize this, if we had a list of 5, 1, 9, and this is a vector with index 0, 1, 2, then this is called vec. Then vec.front would allow us to access the first one here, which is 5, and then back would be this one here, 9. So this is front, and this is back. We use push underscore back here, which is a function that allows us to pass in an element. In this case, let's say it's 4, then we have a vector with 4, and then the next line we have the vector becomes 5 and 6. This updates the size of the vector. So now the size is 3, but the capacity really depends on how the vector was initialized. So then we have the pop back function, which pops the element at the back of the list, which is the last element here. This one also updates the size of the vector, but does not update the capacities, because it just removes the element from here. And the capacity really depends on how it was initialized. For that reason, we have this helpful function called shrink to fit. This allows us to set the capacity equal to the size of the vector. Imagine we had a vector of size 20 and capacity of 20. If we wanted to add one more element to this, we would need to double the capacity to be 40 in this case. Now, if all we needed was to add one element, then we have allocated memory in this vector for a lot of elements that are being unused here. So shrink to fit allows us to shrink the capacity of the vector so that it's equal to the size, and we don't have any allocated memory that we're not using. Then we have insert and erase. Insert allows us to insert an element. It takes in 2 arguments here, this one and this. The 3 is the element we want to insert, and this is basically a pointer to the beginning of the vector plus how many indexes we want to insert the element at. So if we go back to this vector example here, vec.beginning would point to this element here, plus 2, then we would be at this second index, and then we would insert 3, so this would be replaced by 3. We'd always need to start at the beginning and then add according to how many indexes we would like to move on. The erase takes in just 1 argument, and it removes the element at that index. Again, you cannot directly insert the index. You have to start from the beginning index, and then, or pointing to the beginning index, and then add however many indexes you want to move forward. The way we access elements in vectors is really similar to arrays. Inside these square brackets, we just pass in the index and we're able to access that element directly. And here we have a few more operations. Vector.capacity here gives us the capacity, or how much the vector can hold. We could traverse vectors just like arrays using a for loop. We start from the 0th index up to the size, which, just a reminder, is always 1 greater than the index, since the index starts from 0. So a vector with 4 elements has size 4, but has only has 0, 1, 2, and 3 indexes. Then we have vector.empty, which is just a function that returns a boolean, either true or false if the vector is empty. We also have a bunch of other operations like resize, sort, and reverse. Resize basically sets the size and capacity both equal to the argument that you pass in. So let's say we have a vector of just 3 elements, so 1, 2, and 3, with size 3 and capacity of 3. If you resize it to 10, then both would become 10, and it would populate the rest of the vector with zeros. Now let's say that what if that argument was, or that we're resizing the vector to a number that's less than its current. So currently we have a size 10 and a capacity 10. Let's say that it's changed to 3. Then it just leaves us with the first 3 elements and updates the size and capacity to also be equal to that argument. In sort, we just pass in the vector beginning and vector end. Those are both pointers to the beginning and end, the elements at the beginning and end of the vector. And similarly for reverse. This one sorts the vector in ascending order, and reverse just reverses all the elements in the vector. And then we can find the maximum and minimum through these operations here, as well as the frequency and so on. There are other operations, but those are the ones that I think are important to know, just to keep in mind that you can perform many operations with these. You can also clear a vector using this operation. And lastly, I just wanted to go over these operations again. So front provides with a reference to the first element, so we can access that element directly using this function. So if we had a vector called vec again, if we use vec.front, we access the first element. Back is the last element, and it behaves really similar to front, in which it provides us with a reference and access to the last element in a vector. On the other hand, begin and end provide a pointer to the first element and a pointer to the last element. And those are used in the sort, reverse, as well as the max and min functions.